especially in pre-calculus. It's so difficult. So, yes, I'm ready.
The limit of x cubed as x approaches 2 equals
Oh, it's the precise definition of the limit? Okay. Yes, yes, yes. Because I did not, if you remember, I said a minute ago, I did not show in the I said I'm going to make these optional, and I will explain why, and we can look at this. But I will not ask you a problem like this. But since you're asking, I'm gonna show you. Okay. So first of all, is this true? Is the limit of x cubed as x approaches to 8? Yeah. Okay. So this is equivalent to saying, in other words, and forgive me, but I will write the symbols. It's the same thing. You can write it in plain English. For every epsilon greater than 0, I will find a delta greater than 0 such that 0 less than x minus 2, of course, less than delta, will always imply that x cubed minus 8 is less than epsilon. And we know what all this means, that if I pick x close enough to 2, f of x, which is x cubed, will be close enough to 8. Okay, so we start from the beginning, from the end. So I start with x cubed minus 8 less than epsilon. My only chance is to remember how to factor this. So this is x minus 2, and of course, I know what I'm after, right? So x minus 2, and this is x squared plus 2x plus 4. So let me remind you this formula. So less than epsilon. So let's stop for a second so I can refresh your memory on this. It should be in the front cover or back cover of your book. So here it is. So a cubed minus b cubed is a minus b, a squared plus ab plus b squared. So that's what I did. So x cubed minus 8 is x minus 2, x minus 2. This is x squared, and then plus the product, x times 2, which is 2x, plus the second term squared. So this is mandatory. This step is absolutely necessary. Factoring the difference of cubes. So this is the difference of cubes. If you have your book, it should be in the front cover or back cover of your book. Okay, now after we factor, I have to quote that property, right? That the absolute value of a product equals the product of absolute values. That's what I wanted to show, not jump ahead. Just this is. Okay, so then from here, I have the absolute value of x minus 2 multiplied by x squared plus 2x plus 4 less than epsilon. Everything good so far. Now, you may remember or you may not remember, this piece is always strictly greater than 0 if it comes from cubes, because it can come from the sixth and something else may happen there. But this piece is always greater than 0. You can say, of course, it has the absolute value in it. No, the point I'm making is it doesn't really need the absolute value. It's always positive. So if you want to graph this, it will look like this. It will always be positive. It will never touch the excess. If you set this equal to 0, you'll find imaginary solutions. So this is always a positive quantity, so I'm going to drop the absolute value around it and divide by it because it's never 0. That's the reason why I will drop the absolute value and also divide by it. And you can say it's done. No, far from it. Far from it. It's not done. So the problem here is now I have to estimate. I have to estimate this piece. And here's how I do it. Okay. That's why I did not require you to do this, because I think it will take some time to practice this and understand it fully. So, but as I said, since you asked, I have to do it now. Okay, so I need to come up with an estimate of this, because delta depends on epsilon, not on x. This should not be here. So I should have some sort of approximation of that quantity. And here's how we come up with it. Now, the absolute value of x minus 2 will be less than, what do you think? And you can say delta. True. But since we are talking about epsilon around the limit, so tiny, because that's the constant of the limit. I can make that so small as I want. I will always find the delta around 2. So the delta around 2 cannot be more than 1. And you can say, are you coming up with this out of the blue? Not really. It cannot be more than 1. We're talking about tiny. 1 is huge. Why do I have to make this assumption? First of all, for simplicity, because 1 is very easy to handle here. I can say, you can say, for example, no, I don't want that to be 1. I want it to be smaller than 0.2. And then I will have to replace this by 0.2. But my calculations will be more cumbersome. So 1 is okay. Number 1, because it's easy to calculate. And number 2, delta should not be more than 1. The distance between x and 2 should definitely be less than 1. So when I pick x next to 2, it should not be 3 for you. I'm sorry. It should not be, yes, 3, and it should not be 1. It should be much closer. So if I say less than 1, I'm safe. Okay, now I'm going to solve this inequality. And I remember how to solve an absolute value inequality of this type, which is this. I will add 2 to all 3 sides, and I have 1 less than x less than 3. With this information now, I'm going to try and build this. I want to build x squared plus 2x plus 4. Slowly but surely. Okay, what do I have to build first? From this inequality, I need to build what first? In order to slowly construct this, what should I build first? What is my first step? I need to build which piece I have to start with? Squared. I have x, right? I have to build x squared. Knowing that x is between 1 and 3, I'm safe. I can square all 3 sides. I'm not allowed to do that in an inequality, but I'm safe now because all these numbers are positive. 1, x, and 3. So I will square them to get this piece. Okay, now what do I need to do? I need to construct this. But I have to come back to the original inequality, compound inequality, and I'm going to do what to both sides? To all 3 sides? To construct or build 2x. Everything by 2. So then I have 2 less than 2x less than 6. Now I want these 2 pieces together in the same inequality. What should I do to these 2 compound inequalities in order to get this piece together? Add them. Very good. Stay with me. I'm adding now. 3 less than x squared plus 2x less than 15. Final step. I'm closer to building this whole thing, but I'm missing 1 piece. What should I do to all 3 sides now to get that in the middle? Of course, I'm going to add 4 to all 3 sides. So then I have 7 less than x squared plus 2x plus 4 less than 19. Now, here's a question for you before we decide. We are done. We just have to make a decision. I have to come back to my inequality. Discuss this for a second. and then make a decision. On the first example, and I can go back. On the first example that we looked at, that one that I explained a few times just to make sure that we are on the right track. Where is my first example? Right here. This bottom y value was giving us this red interval. The top y value was giving us the blue interval. Which of these two we had to pick? The blue or the red? The smaller of the two. Perfect. Okay, now I'm coming back here. I'm telling you that this expression is anywhere between 7 and 19. If I divide epsilon by 7, do I get the blue interval or the red interval? I get the blue, because division by 7 will give me a bigger number for delta. Excellent. Coming back here. I know that the second option for this is 19. Coming back to my example from last time. If I divide epsilon by 19, will I get the red or the blue? Which of these two numbers I have to pick then? Do I pick 7 or do I pick 19? 19. So I will say, because remember, I already made some assumption for delta. Arbitrarily, I said delta cannot be more than 1. Then as a final result, I have to say, pick delta to be the minimum of these two numbers. One that I started with as my arbitrary number, or epsilon over 19. I wouldn't say that this is beyond the scope of the course, but I'm just saying that, but thank you so much for asking. I really wanted to show you an example like that, but it's a little bit more time consuming. And I need to work more than on just one example on this. Ben, are all steps understood? It all depends on this. I have to start with some assumption. Now, if you block me and say, I don't want 1, I want 0.2, all my calculations will be more difficult. Because, 1 is elegant, 1 and 3, blah, blah, blah. These numbers will become more difficult to work with, but I will get the same thing, but just a smaller interval, even smaller. Very good. Good question. Anything else? Is there anything else you worked on? I am not going to test you on something like this. I will only test you on linear functions. Yes?
Did you 11 on?
Yes. 11 on? 11 on?
Page 106.
106. I just didn't hear. I'm sorry. Do I need the book, or can you give it to me, or? Yes? Okay, good. I'll do anything, then open that.
The limit of x squared minus 6x plus 5 over x minus 5 as x versus 5.
Good, perfect. Okay, we're given a limit. What is the very first thing that we have to do? Mandatory.
Yeah, factor it out.
0.
Plug 5 in. That's our first step. We don't know what to do. Maybe the answer is 1/3 and I don't have to do anything. Right? So it is mandatory that we plug in 5. Okay. If I plug in 5, I see the denominator is 0, and I see that the numerator is 25 plus this, which is 30, and this is negative 30. 0 over 0. What does that mean? Yes, it doesn't say you will find the limit. The limit exists. It just says it's not the other one that is completely blocked, that cannot exist. Good. Now, since I plugged in 5, and I get 0 over 0, and this is very important to remember. What do I know for sure? That the top and the bottom have a common factor of Indeed. Indeed. Yes. So that's my next step. I'm quoting two theorems from a previous course. That's what I'm doing. So this is limit as x approaches 5, and this is x minus 5, and this must be x minus 5. My markers are going berserk. Okay, and then what is the other factor? That's it. Good. So therefore, what happens next? Finally, remember, please, I did not drop the limit operator. Now I can drop it because I plug in 5 again and I get this. The limit operator disappears at the very last step.
So
Yes,
in a
Tommy?
test situation, if we didn't throw in the limit operator, right? That would
Right, but look what happens.
Yeah.
Do you, can you tell me that x minus 1 equals 4? No. But you can tell me that the limit as x approaches 5 from x minus 1 equals 4, and then I accept that. So the limit operator is part of the problem till you plug it in at the end and you write a number. So please pay attention to that. Yes, anything else? Anything else?
Can you do number 11?
Yes,
117.
117. Do I need the book?
Yeah.
Oh. Okay. (11) or 117? 11. Okay, so we go to manufacture this with an area of 1,000 centimeters squared. What radius produces such a disk? Okay, so the area is pi r squared. So that's part A. So that will not be a problem, right? That is the problem?
No.
Okay, part B. Okay, let's see. Unit is allowed an error tolerance of plus or minus 5 centimeters squared in the area of the disk. How close is the ideal radius in part A? Mass dimension is okay. Good. So, what is this plus or minus 5 centimeters squared?
The area of 1,000. So 1,005 and 9.
What is it exactly? Stay with me, don't say anything. What is it exactly?
Area. Oh,
It's not.
epsilon.
Exactly. That's my epsilon. It's centimeters squared. So it's the function, right? And the function. It's not here where I have centimeters. It's here where I have centimeters squared. So that must be epsilon. So then this, I don't know what this is. We haven't discussed it yet. But definitely, if this is 5, this point is 5 minus 0.5, and this point here is 5 plus 0.5. We agree? Okay. So let's come back. So then epsilon is plus or minus 5. So whatever this is, I have this, I'm going to call it L. This is L minus 0.5, and this is L plus 0.5. Let's see what they want next. So it's allowed to an error of tolerance, okay, in the area of the disk. How close to the ideal radius in part A must the measurements control the radius? So whatever the function is, right, it's a quadratic function, but whatever it is, so this will be our A, and we're asked to determine delta. So A plus delta, then A minus delta. Okay, any suggestions? Did you determine the radius? Because I didn't. I didn't determine the radius from part A. What is it?
It's 10 times 10 pi over 5.
Yeah, just an approximation. So Okay, so let me do this then. So r squared equals a divided by pi. So r equals the square root of 1,000 divided by pi. So what did you get when you took the square root? So I have 1,000 divided by pi, and I got 17.84, approximately, centimeters. Okay, so this is our number here. So we're asked to determine. So in other words, we are told this: the limit as r approaches 17.84 from pi r squared is 1,000. So the limit as r approaches 17.84 from either side of pi r squared, which is our function, is 1,000. So whatever it is, function, I don't really care. So this is it. This is a point on the function, which is 17.84 comma 1,000. Do we agree with this? Okay, so this is given to us, in other words, because we determined the radius, and this is given to us. And we are given the epsilon, and we're asked to find delta. So which delta will I find? Around 17.84, which is the tolerance for the radius, when the tolerance for the area of the disk is 1,000 plus 0.5, 1,000 minus 0.5.
What do you mean 5? I thought it was 5.
Oh, was it 5? I'm sorry. Sorry about that. For some reason I read 0.5. Sorry. Sorry. Thank you. Very good. So yes. So in other words, this is 1,000. So this is 1,005, and this is 995. Okay, good. So what do we have to write?
Plug in 1,005 to pi r squared.
Yes. So you want to plug 1,005 into pi r squared. Okay. So the area of 1,005 will be pi times 1,005 squared. And that should be the same with the area at 17.84 plus delta. Right? Oh, this is not the area, but it's 1,005. Oh, see? That's wrong. So the area at 17.84 will equal pi times 17.84 plus delta, which has to equal 1,005. Not your fault. I wasn't writing it correctly. Good. So let's see what we get. That's squared. So pi times 17.84 plus delta everything squared has to be 1,005. So 17.84 plus delta squared has to be 1,005 over pi. Now I'm solving for delta. I take the square root from both sides. 17.84 plus delta equals, it should be plus or minus, but 1,005 divided by pi. So then delta equals 17.84 minus the square root of 1,005 over pi. So I'll plug this in the calculator and I'll determine delta. 17.84 minus the square root. Did we get this? If you have the number, don't torture me, give it to me.
If you subtract it, I mean,
Yes. So I got the delta is approximately 0.04578. Did you get the same thing? So what would you say to the machinist? You're going to say that to him this, him or her. You're going to say if the tolerance on the area of the disk is plus or minus 5, then you'd better not make an error, of course in centimeters, you'd better not make an error in the radius of the disk of more than 0.045788 centimeters. In terms of the epsilon delta definition of the limit, what is x? What is f of x? We already used all this. What is a? What is L? What value of delta is given, of epsilon is given, and what is the corresponding? Is this clear? Do I have to state part C? Is part C okay? Okay. So the epsilon is 5. The delta is this that we just determined. A is 17.84. L is 1,000. And I think we answered it all. Good. Very good point. Very good question. Thank you for that. Yes. Anything else?
Can you do number 7 on
Yes.
117?
7 on 117. Okay. It's the same thing. It really is the same thing. So you're given epsilon, and you have to solve the equation exact same way. Let me set it up for you, and then you can solve it from there. So this is what we have. We have the limit, which is 6. So we have 6 plus 0.2 or 6 minus 0.2 in here. And by finding delta, right? So delta is around 2. Was it 2? Yes, 2. So we want to find 2 plus delta and 2 minus delta. Okay? So this value, assuming that here's the function, this will be 2 plus delta, comma, f of 2 plus delta, and f is x squared. So f of 2 plus delta. And the function is x to the third minus 3x plus 4. Okay. So all I have to say is that when I plug in 2 plus delta cubed minus 3, 2 plus delta plus 4 must equal 6.2. You have to expand this. They have to distribute here. So the formula for this, a plus b, we don't do this. We don't present those formulas. But from Pascal's triangle, we know that this is a cubed plus 3a squared b plus 3ab squared plus b to the third. So the first term cubed will be 8 plus 3 times 4 is 12 delta plus 3 times 2 is 6 delta squared plus delta cubed. I see the difficulty. Let me finish it then because it's minus 6 minus 3 delta and minus 2.2. And if you use maple on this, it will give you an answer in a blink. But since I can show you a different way, because it will take me a minute to bring up maple. So this is d to the third and plus 6d delta squared. And then this is 9 plus 9 delta. And this is negative 0.2 equals 0. I'm not sure why we don't sell TI-86 anymore. That's my favorite calculator. It has, I think I have it. It has a feature called polynomial, and it solves. Here it is. That's the best calculator I've ever had. But I don't think that they are producing those anymore. So here it is. It has a feature called poly. It's right here. So with second and poly, I say the order is 3 because that's the degree of the polynomial. And it's asking me for the coefficients in descending order, which is 1, which is 6, which is 9, and which is negative 0.2. And then you just click on solve. And you will think for a while because it's okay. So it gives me 3 solutions. And I bet, yes, the first 2 are imaginary, complex imaginary. So the only real solution is 0.0219. So the only real solution, 0.0219. I love this calculator. It's the closest to Maple that I can get, this calculator, I think. Yes, there are other options. You can, you don't have to have this calculator. So here's the other option. I should have been ready with that. Okay, or Maple. Maple is awesome. So in y equals, you put in the function as x cubed, and then plus 6x squared. Of course, I always do that. Plus 6x squared, and then plus 9x and minus 0.2. Thank you for asking this problem, okay? Because now I realize what the difficulty was. And I know the delta has to be a positive number, and it cannot be a huge number. It has to be tiny, between 0 and 1. So I'm going to just change the viewing window. I only want to see, let's say, -1 to 6, and -2 to 10. Yeah, I shouldn't even go that much. So, of course, that's a problem here with a scale of 1, and minimum -2 to 5 with a scale of 1. And then I can hit graph. And as you see, it's so tiny. I've got 0.0219. So once I graph it, I can go to a second and calc. And I will say I want the 0. 0 meaning the x-intercept, the 0 of the function. So I want 2. It will ask me for a bound. Yes, of course, I know delta cannot be less than 0. So I'm going to say 0 to 1. And no guess. And it will give me this 0.0219. It has to be, because this is a very good calculator. So that is the answer. So that's the other option. Once you have the function, plug it in the graphing calculator, use the 0 to find the x-intercept. But yes, it takes you a little bit longer than just a poly feature, but they did not put that feature in any of these calculators. I'm not sure why, because it's very powerful. Thank you for asking that question. And you will repeat the same process with 0.1. Any questions on how to repeat it? Oh, sorry. Any questions on how to repeat it with 0.1 instead of 0.2? Is that okay? Okay, very good. Other questions for me? Anything else? Anything else? And I do have a quiz for you for today, a couple of minutes. Open notes, open book, just not your neighbors. Couple of limits, nothing fancy.